Hi, GED class. Welcome to our next week here in our class. And I wanted to come in here and do a little presentation on our GED science exam. Um, I know a lot of you are preparing for the official GED exam and looking into the different areas of the mathematics and the science right now, which is great because those are the two most dense as far as the material goes and all the different components that we're taking a look at, we're reviewing. But with the science specifically, as I was talking in our last video, regarding the chemistry, the biology, the physics behind all the components here. The reading is a key component. So that is what we want to focus our strength for the exam here, is making sure we read properly the information and we can see the patterns as we are taking a look at the reading. So that is our main component here. So you don't have to worry too much about knowing everything about the biology, the chemistry, the physics, the anatomy behind the components. It is in the reading. The secret is that the reading will give you the information that you need as far as the answer, and you'll be able to find the answer just by following the patterns there. And so we're going to take a look at today at a practice science exam, just like it is on the official GED exam. And you can see for yourself that there are some strategies that we can follow to help us find the right answers there. So let me share my screen here, and I'm going to go directly into the GED website. As we are familiar now with this because we've been taking some practice GED exams. And obviously the official GED is very similar to those, just a lot longer in length. So let's start. That's our science practice. I am going to go down here and click next, and let us take a look at some of these questions here one by one. So as we can see here, we have a map. So there's a little bit of geography. It says the map shows Earth's continents, the outlines of the plates that makes up Earth's outer shell, and the locations of the volcanoes. And obviously here we can take a look at everything that is happening in the picture by highlighting the area where those volcanoes are, right? So you can see here, I'm going to kind of like help you out from a visual aid where these yellow dots are, right? So they're located in this area here, and then you see a little bit on the European and African continent in here. But you can see pretty much where the active volcano is. Now, if you ask me, like, how do you know where the active volcano is? They're going to give you a box where it's going to be representing what those things in the picture are. You don't have to know exactly the images. So they're saying that the yellow is an active volcano. The black line is a plate boundary, and the red one is the equator, which is in the center of the globe there. So as you can see here, the active volcano, if you take a look at it, it is very much where those plates are, right? It kind of follows through the pattern of the plates. Now, if you ask me, Mr. Eitri, what's going on here? Why? Well, the plates are hitting one another in that spot. And so every time they hit and they collide and they cause friction, they jump on top of one another, that's where the volcano is going to, erupt and appear because of that action reaction, right? So this is how we take a look at this. And once we do, then obviously we can, go into the question now. And the question, again, always keep in mind, what is the question about, right? It says, which conclusion, meaning what do we see, what do we understand out of the big picture, is reached from the information on the map. So we do have option A, by elimination, like we always say, volcanoes are scattered randomly, right? So option A says there's no pattern, random. Option B says volcanoes are only located along the edges of the continent. Now it says only here, which we don't like that word, because how do you know that's only there? I mean, we get to see some of them are in other positions. Like I see some right in the ocean here. So then C says volcanoes are mostly located along the boundaries between the plates. Like we said, most of them. So I like this word. And D says volcanoes are distributed equally in the northern and the southern hemisphere, which it's not, something that we can see here. Also, we see that in the northern hemisphere, it tends to be more of them than in the southern under the equator. So that equally, it makes a big assumption in the scenario here. So with that in mind, you can say, you know what? We like option C, where volcanoes are mostly located along the boundaries between um, the plates, because when those pretty much friction and movement is occurring, that's when we see some of those things happening in here. So now what's really cool about this platform when you go to your practice exams is that you can actually check your answer. You can flag for review. So when you flag this question for review on the official exam, what's going to happen is it'll allow you at the end of the test for you to go back. And when you go back, you can review this question. And then you can click again and it'll unflag it. Another thing we can do here is we can always take a look at our answer explanation when you're taking those questions that are practice questions. And when you go to the answer explanation, it's really interesting because it'll give you some more details. Like they're saying option C is correct. If you choose this option, you notice that the map shows that volcanoes are mostly located along the black lines on the graph. So it's the rationale that we are doing. That's what we call this, the rationale, the reasoning. And when you see the reasoning behind each answer, you can see what errors we possibly made, and what are some things that we want to do better next time around here. So, okay, so let's take a look at our next question in here. We have a diagram here where we can see the diagram below. It's our, they call this the Bloom's taxonomy. A lot of times we use this for learning purposes too, and the learning pyramid. But it shows us pretty much like a chain of what is important and how things are connected to one another. So this is a typical energy pyramid. And we have on the top here our tertiary consumers. Right underneath them are the secondary consumers. Right underneath them, we have primary consumers. And then in the bottom are the producers. So you can see here how the producers are majority of the pyramid. Can we connect with this? Of course, producers, right? People that work for others. So people like you and I are producers for the primary, our bosses, and then they are, pretty much consumers of their bosses. And then, we have the tertiary consumers that are the toughest part. So with energy, that's how that works, obviously in here as well. So with that in mind, we can see now what is the question. After you look at the chart, you visualize it, you try to understand what's going on. It says which statement correctly, so you want a correct statement, describes the flow of the energy through the pyramid. Now, you might say, what is the flow? it's pretty much like a path, right? Like from the top to bottom or bottom to top. It's got to flow. You have to follow this picture. You don't have to know this picture. You don't have to come up with a theory. You don't have to know a formula or why are they going from one to the other. It's already set in stone here. It's already drawn. Even if the titles are rearranged, that is the picture that we trust, right? So we go from producers to primary, secondary, tertiary, and then also backwards. So what are we going to do? We're going to do what we always do. We are going to use the process of elimination, meaning we're going to read each answer and make sure that we find one that is true for this particular scenario. So A says all of the energy from the lower levels is available to the other levels. Maybe, but let's say that somebody is right here in the producers. How can tertiary consumers actually gain from the producers immediately, right? There's a couple of layers in between here that secondary and primary that are not allowing them. So it's almost like you saying, I want to go from the first floor to the fourth floor immediately. No. So that's why I'm not going to go with A. B says the producer level directly provides energy to all of the other levels. Well, the producers are directly connected to the primary consumers. That's it. Producers and consumers are connected here with one another directly, but not directly, meaning without going through the chain into secondary consumers, right? So C says the highest amount of energy is transferred between levels that contain consumers, but producers are the largest. And D says energy is directly transferred from the primary consumers to the secondary consumers, which we can definitely see here. It is true because primary and secondary are separated by one line between one another, right? We have primary right here and we have secondary right here. So these two are definitely directly connected to one another. We have secondary up here, we have primary up here. So definitely directly transfer, directly connected, right? There's two types of connections. Direct, when you know somebody and you're directly connected to them, or indirectly, when you are connected to a person and then that person or that entity or that organization is connected to another organization, and then it's indirectly. So that's what's happening in this pyramid here. The producers are directly connected to the primary consumers. The primary consumers are directly connected to the secondary consumers and the producers, that you can go up or down. And then the secondary consumers are directly connected to tertiary consumers and the primary consumers. And then the tertiary consumers are only directly connected to secondary consumers. So it's interesting how it works, right? And there's so much theory behind this and how much we read, but this picture, it's truly 1,000 words and even more. It gives us so much information. Now, but you do have to read it properly. That's the key in science, to take a good read of the information here. So very important. And again, you can flag it for review. You can click on, the answer of the explanation here, and you can see basically the same thing in here, talking about the transfer directly from primary to secondary, which is, option D that we obviously went with as well in here. So, okay, let's take a look at a little more of a challenging question. So in this question, we are looking at a graph, a chart with information. And the first thing that we have to take a look at when we look at this is the titles. We have to truly take a look at what those titles are representing, right? So on the vertical part, we have the word increased solubility. In the bottom on the horizontal, we have temperature. By the way, it is very important that we know both of these terms. Horizontal means left and right. Vertical means up and down. So in the horizontal, we have temperature. We know what that means. And it goes from 0 to 100 here. In the vertical, we have solubility. Now, you might say, what is solubility? What does that really represent? Well, let's do a little mini lesson while we're in this question here. And think about if you have a container here, and the container is pretty much filled up with a fluid, some sort of a liquid. And next thing you know, you are adding some solid inside this liquid. So you have some solid particles, and you want to add pretty much those solid particles inside the liquid, and you want to dissolve these solid particles inside this liquid. So when you start dissolving them, you pretty much are talking about solubility. In the morning, you put creamer inside your coffee, or sugar inside your coffee, or salt in a pot of water when you're cooking, and then you're mixing it. That's solubility. You want things to dissolve, right? As the temperature goes up, as you can see here, the solubility for most of these chemicals, that, by the way, you can see these chemicals right here on the box. So you know every color, what chemical is it represented by, which is great. Each color has a chemical, and you can see how it reacts as the temperature gets bigger. Most chemicals, as the temperature rises, they dissolve faster. It's easier to dissolve. Think of when you're stirring something, when you're mixing something, it dissolves quicker. So that's what we're taking a look at. Some of them, that's not the case. Possibly this thing right here. So I can see how this purple one, it is not following the path of the other ones. It seems like as the temperature goes up, the solubility kind of like plateaus, stays straight, but the rest of them, they seem to be going up, some quicker than others. And we know that with chemicals, some dissolve quicker than others here. So it makes sense, but that is the idea of this picture, right? It's a lot of information, but it's very helpful for us to understand it, right? We don't need to know anything about the solubility of each one of those chemicals. If you don't remember the name of these chemicals on the right side, like sodium chloride, potassium chloride, you know, cesium and lead, and any of those chemicals, nitrates, sulfates, you don't need to know them. We just have to read the picture, right? So now let's check the data. It says conclusion, right? Meaning let's find out, what can we see? What do we see in this picture? It says which conclusion is supported by the data in the graph. And supported meaning it's true, it's a good answer. So option A says solubility always goes up as temperature increases. Always. Almost, right? It did go up for all of them except for this guy right here. So that's why we cannot go with that. Next one says at 40 degrees Celsius. So let's find 40 right here. KCl, which is the green one from the box, we're going to find it. We're going to go up here and find the green one. So at this spot, okay, says has the highest solubility right there. They're saying that is higher than anything else, higher than the blue, higher than the red. I don't think so, right? So that's not going to work either. No A, no B. Let's check C. The rate of change in the solubility of KNO3. Now let's figure it out. KNO3 is the blue one. So we can see the blue one there. Changes as temperature is increasing, meaning this thing is changing up, and let's take a look. Let's see if, that is true. So we said that basically this KNO3 is the blue one. We can see the blue one right here. And it does seem that it's a curve. There's a change. It's not staying straight. It's not actually cooperating with like a linear form, like a set form. It's actually changing. So I like this answer. And then this is the solubility of NaCl, which is the orange one. And we can see the orange one right here, right there. It says that it does not increase above 80. There's 80 right here. Not true. It continues. It continues to go, but it's slow. So best answer here in this very challenging question, in my opinion, would be actually answer C. The rate of this KNO3, meaning how it changes because there's a curve. Curve means that you are constantly changing. If you're a straight line, you have the same rate. You're going with the same path. But if there's a curve, that means that there's a bigger change in here. So another tough one, but again, we have to rely on our chart, our tables, our picture, and the interpretation of what those pictures represent. That is the most important part here, not any of the other components that we might, think they make a big difference. So we have to be very, very careful. Let's take a look at this next one in here. We have Newton's second law, it says. Now, overall, Newton talked about forces, pushing something, pulling something. And that is what's happening right here. We have, our Newton, who is mentioned in this here, in this question. You don't have to worry about Newton's first law or second law or third law, because they will not ask you specifically what are they. They will just give you a chart and ask you to see if you can see a pattern. If you can develop a visual interpretation of that pattern, then you'll be great. You'll be able to. So here we have a net force, and we can see the force. Then we have mass. Then we have acceleration, how something is moving, how something is speeding up. So let's check it out. Let's see how does this work, right? Let's see how is it. We have the force is 8, mass is 2, and acceleration is 4. Okay, then when the force is 8, mass is 4, acceleration is 2. Okay, so now the mass got a little bigger, you're heavier, therefore you're not moving as fast. Makes sense. Then the force got, much higher. You're pushing something with a much larger force. And as you're doing that, you have a very small mass. So of course, that object is going to travel way quicker. And it's traveling with 8. If the force is 16, staying the same, but the mass is getting a little bigger, now the acceleration is going to get a little smaller than earlier. So we can understand this. If we have a very large object, it's really difficult to push it, really difficult to accelerate it. If we have a very small object, it would be a lot easier to push it, a lot easier to accelerate it. And that is our main key here. Another thing that you can take a look at here is that if you multiplied the mass by the acceleration, you will get the force. And actually, that is Newton's second law. Newton's second law says the force that you're applying into an object is equivalent to taking the mass of that object and then multiplying it by the acceleration. So F equals ma. M times A equals F. Um, and that's why you can see here, that's why it's all in the pattern. 4 times 2 is going to give you 8. 2 times 8 is going to give you 16. 4 times 4, it's going to give you 16. So when you multiply these two columns, the second and the third column, you will get the first column because Newton's second law says, and again, you don't have to actually know this, but it does help to know that background information, because now you can kind of see how as the mass gets bigger, the acceleration gets smaller. And as the mass gets smaller, the acceleration gets bigger. Although, again, we said it's a force. And when something's really big, it's really hard to push it or pull it. When something's very small, it's a lot easier to push it or pull it. So now with that in mind, let's try and take a look at the question. So it says, which statement describes the pattern established in the data? Pattern, we got it. That's exactly what we've been talking about, the patterns. So this one says, if you double the force, you increase the acceleration 4 times when the object's mass is constant. It's a little tough because if you double the force, most likely you double the force, you double the acceleration. Whatever the force is, that's what happens to the motion. This one says you double the net force, decreases the acceleration when the mass is constant. The word constant means it is the same. So this one says if I double my force, it's going to be less acceleration on the same mass. How's that possible? It's like if I punch something more, wouldn't that actually move more instead of move less? So I'm going to decline both A and B here. C says you double the mass, decreases the acceleration. Makes sense, because if you get something that is bigger, it's going to move slower by half when the net force is constant. So makes sense to me. You double the mass, you're going to move half as fast as you were moving before, right? It's going on opposite direction. The heavier something is, the slower it's going to move. So I like C. And then D says you double the mass, increases the acceleration of the object 2 times when the net force is constant, which again, if you double the mass, you're going to have a harder time accelerating that object. So that is where we're standing here. You double the mass, it would decrease the acceleration of the object by half if the force is constant. You can also see that right here on the last 2 rows. We double the mass here from 2 to 4. And what happened to the acceleration? It went from 8 to 4 with the same mass. So sometimes, you guys, the answer is right on the table that is provided to you. You don't have to go too far. All you have to do is look into the chart and you can find the answer there. So another challenging question, but we were able to figure out the answer just because we were able to see the pattern in here. So one more question here before we wrap this session up today. And this is our biology question. And we talked about this in our last video, how important it is to keep in mind how the genetic works and overall the chromosomes and the crossing over and, the next generation and the patterns here. The maternal, the paternal. The picture says it all. Again, it says the diagram shows an event that occurs during meiosis. So you might say, I don't know what meiosis is, but you can see what's happening here. It's the crossover, a male and a female. The male is red from what it shows here. There's the paternal. The female is the gray. They cross over. This is the crossover right here. And we get to see these two, which are pretty much the kids of these two, right? So if these two parents had children, their two children are going to look like this. So it seems like the one on the left looks a little more like the father, while the one on the right looks a little more like the mother. We don't know if they're boys or girls. That's all they're giving us. But this is to show you how the characteristics from both the mom and the dad get distributed into the children, right? You don't see here one of them with only the paternal characteristics and one with only the maternal. They have a little bit of both. Sometimes you have a little more than from one parent than the other, but they do have a little bit from both. And that's what they're asking. They're like, what are the results of the event? So, elimination again here. A says chromosomes that are genetically identical to the paternal. So, they're saying here that both of these look exactly like the father, which is red. Not true. B says chromosomes that are genetically identical to the maternal chromosome. So they're telling us that both kids should look exactly like the mom, which is gray. That's another one that's not true. C says chromosomes that are a genetic combination of the parent chromosomes. That's what we're looking for. It's a combination of both in here. So, and then D says chromosomes that contain a different amount of genetic information than the parents. This is if you had the red and the gray, and then the children had, let's say, like blue and yellow, green and brown. Totally different genetics. That's what it says here. Different amount of genetic information, so different types of genetic, which common sense will tell you that's not possible anyways. So as you can see here, overall, going back to our main components of how to do the science exam, it is not as challenging as the math that we have to know. We have to know our pre-algebra, algebra, our geometry, a little bit of advanced algebra with the charts and the graphs. With the science, although there's a lot of information, all we have to do to be successful on this exam is pay close attention to the details, the charts, the tables, the information at hand. We do not have to worry about free response. We just have to make sure that we follow the select, answers out of the 4 or 5 given answers, the multiple choice setup, the idea of elimination technique, uh, save some time, do the reading properly, and we can do this. We can be very successful just using proper critical thinking skills. So with that said, I wish you guys best of luck on the science, and we will start on the social studies and language arts pretty much next week, and conclude with those two. So thank you all for watching this, and I will see you next time. Best of luck. Bye.